Hello! Well, in this episode of Finno Machining, it's going to be all about a butane torch. Yeah, I will machine. Uh, there is nothing, no videos about the machining. I have a bunch of still pictures, but nevertheless, there is machining. Uh, one thread that is left-handed, 19 TPI. Well, threads per inch. Oh, in my metric lathe. Oh yeah. Well, easier than one might think. And then I also present a method of checking your thread pitch. Uh, if you uh, if you have a DRO or a travel indicator like I have, it's very easy to check what is the actual pitch you are going to thread. Because in this case, what I will do, I don't change the gears. I actually found out that this lathe, this is Weiler Matador. It has one slot which is marked as black box in the chart of thread pitches, and as it happens, it's quite exactly 19 TPI. Wow. Well, what do you know? Well, they didn't mark it because it's a metric table, and if you have it there, it's really. Well, I suspect it's not exactly what it is, but accurately enough. And then I'm going to do a presentation why I did this kind of trading, etc. And then that's it. So let's go on with this one. The Propane hose I have has a 19 TPI left-handed thread. The diameter is about 16.6 millimeters. Here I have already turned the measure diameter and the thread relief. First I need to know the metric pitch of a 19 TPI thread. The calculation is really simple. Just divide 25.4 with 19. So, the distance between each thread is 1.33 millimeters. The metric thread pitch table of my Weiler Matador has a black box in a place that might give the correct pitch. I will now measure what is the pitch this setting gives. If I'm lucky, it will be near enough and I can avoid the hassle of changing the gears. First I will connect the half nut and turn the spindle by hand until carriage starts to move. This will remove any slack in the gears and the lead screw. After this I reset my travel indicator and turn the spindle 10 turns. After turning the spindle 10 turns, the travel indicator shows the thread pitch multiplied by 10. In our case, it should read 13.3 millimeters. Lord and behold, this is exactly what it reads. So, no gear change rumba today, as this is good enough. I just could not believe my good luck, so I checked the thread with a thread gauge. It is a perfect match. At this point the half nuts cannot be disconnected. Luckily, my lathe stops pretty fast after I installed a VFD with braking resistor to it. It takes only half a second for this lathe to stop. Since this is a left-handed thread, I have all the time in the world to stop when threading, because the carriage moves away from the spindle. However, fast stopping is needed when I return to the start of the thread, as this must be done by spinning the lathe backwards. The threading went without drama, and the result is exactly what I wanted. This cone is the sealing surface for the propane hose. I used a 12mm center drill to make it. Easy to do, and it is close enough the needed cone. The other end of this workpiece threads into a pipe inside the torch handle. I have now turned the major diameter of the needed M10 thread. Here is the M10 thread with 1mm pitch. I also drilled a 4mm hole all the way through the workpiece. This is now ready to be installed to the torch handle. I used some Loctite anaerobic sealer when installing this. This handle is of a very good quality German-made Exact brand. I have 5 different burners which I would like to use. These are attached with something I do not have. So I make the needed attachment piece. I make the adapter from mild steel rod. Here the shape has already been turned. There will be a M9 thread with 1mm pitch on it. Here the adapter is installed in place. It is ready to be used with the burners. I am now going to show the flames of these 5 burners. I start from the smallest and go towards the largest one. In addition, I will show the special burner I have for brazing. This burner produces the smallest flame of these 5. The flame is small and is well suited for accurate soldering. It can be used to silver solder resistor wires, for example. The flame of this burner is still quite small. It is big enough for brazing very small lathe tools or soldering thick wires. The flame of this burner is big enough for silver soldering small lathe tools or soft soldering thin copper pipes for plumbing. Bigger flame means more energy. So it's for silver soldering small lathe tools and soft soldering medium copper pipes for plumbing. This burner produces a lot of heat. The flame is not that hot, but it is big. So it's well for soft soldering copper tubes for plumbing. This is my go-to burner for silver soldering lathe tools. The flame is concentrated and very hot, being a propane flame. This is because the burner has the air intake near the handle, thus making a better job on mixing the air and fuel. Yes, that's all about Butan torch. I have 2 of those, and the other one has a lever for well, you can boost. There is an idle flame, and then when you push the handle, then you have the actual flame. But most of these nozzles I have, well, they consume so little butane that this handle has no effect at all. So, okay. Anyway, I intended to put some silver soldering here, but well, let that be in some future episode when I will make a tool for the lathe by silver soldering. It's a good thing to do. Oh yeah, and Well, in the next episode we are going to do some welding again. Hopefully the results are not as horrible as the last time. I'm still using the welder here. And about the answers to the some of the questions, there were some forums that presented me some questions. Somebody suggested me to get a better welder. Well, actually, this welder, this Kemppi, is it's a Finnish made, not a Chinese. It has a transformer inside, but it also has electronics. It is a DC welder, not AC. It's DC welder. So therefore, it has those markings that you put your torch here, your stinger here, and your ground cable here, and there you go. And the current adjustment, it's very, very unique. You are not adjusting your current by amperes. You are using like the stick diameter. Well, okay. I'll take that. It's easy enough for if you don't want to know anything about electricity. Then this is how you do it. Okay, that welding will be in the next episode of Finno Machining. I have my plans already ready, so yeah. Till then, bye!